And now, finally, we are in the last part of epidemiology. I know it must have been torturous 3-4 hours for you sitting around and talking about epidemiology all the way. So, beta, in this total last video section in the chapter on epidemiology, this is what you're going to study. We need to talk about what do you mean by the errors in epidemiology like bias and confounding, and how to treat the bias and confounding. Then we will learn about some points about what do you mean by causal association and the criteria of causal association. Next is the summary of everything that you have done in the previous few hours. And last would be just here and there numerical problems. So talking about errors, topic number 1 is about errors in epidemiology, or the problems or the mistakes that we do. What do you mean by error? Error means mistake. So now the mistakes can be of two types. You sometimes do mistake just by mistake. That is what do we mean by a random error. So sometimes we do mistake just by mistake. We say, parents will shout at us like, why did you do this? So we say, by mistake it happened. Or sometimes you are bound to do that mistake. That person is born to do that mistake. He'll do that mistake again and again and again because it's innate into the system. That mistake is called as a systematic error. So the errors or the mistakes can be of two types. You can have a random error, which is a mistake just by mistake, or a systematic error, which is always going to happen. Beta, please note for your exams that what do you mean by bias? Bias is a systematic error. Bias is not a random error. What do we mean by the random errors? The random errors are called as the sampling errors. Random errors are called as the sampling errors, whereas bias is systematic errors. So now let us talk about bias a little bit more in detail. There are many types of biases which you would like to talk, or these are the systematic errors which are always going to be there in the study. So some of the few biases you see on the screen, we can talk about how many are these? 6 biases. 1, 2, 3, 5 and 6 biases. So what do you mean by observer? Just one line about them. These are not very high yield, but as a student, you should be knowing what are these biases. What do you mean by observer bias? That means the doctor or the physician or the nurse, whoever was observing, they are biased. So if you give differential time to the subject, that is what is you are biased. So that is observer bias. It is a bias of the doctor or the nurse or the physician who is actually checking the patient. So that is what is observer bias. What do you mean by interviewer bias? Interviewer bias could also be a type of the observer bias because the person who's doing interview, but specifically the person who does interview, if they are biased, that is called as interviewer bias. In the MCQ exam, MCQ will be very straightforward. If you are giving differential question, level of question. So if you are asking leading questions or differential level of questions were asked in an interview or in different Viva exams, this is called as interviewer bias. Sometimes examiner will ask you very easy question because they are preferring you. So that type of bias is not an observer bias, that is typically interviewer bias. Next is, what do we mean by the experimental bias? Beta, in the experimental bias, it is not a problem of the patient or the subject. It is not a problem of the observer. The experimentation system is problem. The intervention that we are doing is a problem. So if the MCQ says direct MCQs, if there is differential procedure or there is differential device to investigate, or there is a differential criteria to define. So anything, differential procedure or device or criteria or tool to find out something is different in different groups. That is called as experimentation bias. In very simple language, let us say I was having group A and group B. I was supposed to check their blood pressures. In group A, I used a digital sphygmomanometer. In group B, I used maybe a hand sphygmomanometer, normal, old conventional type. So the tools are different now. So the values will kind of vary. So in diagnosing diabetes mellitus, OGTT is used, or the fasting blood glucose, in different surgeries, different procedures. So everything is what is experimentation or the experimental bias. What do you mean by recall bias? So I hope you understand very simple words. What is observer, interview, experimenter? What do you mean by recall bias? Recall bias, a lot of MCQs come on this. There's a 3 by 5 star MCQ topic. What is recall bias? Recall bias, it is a specific bias found in case control studies. It is a specific bias which is found in case control study. What do you mean by recall bias? Recall bias, I'll write it on a separate page. Recall bias is differential ability to recall between cases and controls. Many times, in fact 99% of times, the students makes a mistake that, sir, in cases and controls, the controls were not able to recall, or the cases were able to, or cases will not able to. It's not about the people were not able to recall. It is the differential ability to recall. Let us say that I divided into, let us say that we don't divide, no case control. Let us say you went to outside at 2 a.m. in the night to have ice cream. Sometime you were getting bored after studying epidemiology so much. So you went outside that my head is getting warm now. I want to go outside, freshen up and have ice cream. You go have ice cream in the midnight at 2 a.m. and next day morning you come with fever. So you say that I got fever here, my throat is sore throat now. Why? Because I had ice cream yesterday, forgetting that thousands of times you must have gone outside to eat that ice cream. That time you didn't get anything and you never bothered. So in very simple words, when we are doing a case control study, the cases who have suffered, you got the disease. So people who suffered will always try to associate something. They will say that I did this and then I got this. People who are healthy, even if they would have taken 1,000 ice cream, they will not have said that it is because of, I am okay because I took ice cream. Are you getting it? So the cases and controls, they have a differential ability to recall, because the poor fellow or the people who suffered that disease, they will have more stronger association with whatever you ask. So that is what is important for you to know. It is found only in case control. Not only, it is found predominantly or specifically in a case control study. What do you mean by recall bias? It is a specific ability to recall between the cases and the controls. Coming over to next, what do you mean by surveillance bias? Surveillance bias is a finding bias. So mostly when we are doing cross-sectional studies, or mostly when we are doing, in fact, not only cross-sectional studies, we are doing any type of observational studies. In those studies, we have a special bias called as surveillance bias. Surveillance bias is getting more disease, more events are observed. Why more events are observed in designs? Why? Because we try to search more. You search more, you find more. Simple. There must be some PSM notebooks, community medicine notebooks, which you would have written in first year, second year. Where are they right now? They must be lying somewhere in the cupboard, or somebody must have, they are lost. When you are searching for biochemistry books, you will find a community medicine book also. And there was inside some rose flower, you will find. So you search more, you find something more. So you search for one disease, you find so many other things. That type of bias is called as surveillance bias. So surveillance bias is usually found in observation study. The events were actually not recorded because nobody cared to find them. So that is a bias called as surveillance bias. Reporting bias is the similar kind of publication bias, where what is going to get reported more, what you find more. So reporting bias is similar to the publication bias. In publication bias also, you remember that there was a drawer effect. In the previous module, we talked about publication biases and the reporting biases. They are very similar. Now moving over to some of the heavy biases. These can be again asked in your exam. So how many we see? We see 6 more of biases: 7, 8, 9, 10, 11 and 12. What are these biases now? These are like high yield MCQ topics. Point number 7. What do you mean by the Bergsonian bias? Bergsonian bias. Beta, Bergsonian bias is a differential hospital admission rates. It is a differential hospital admission rates. That means different hospitals will cater to different type of level of diseases. A primary care cancer hospital will have different diseases. A tertiary care cancer hospital will have entirely different set of problems. will have different diseases which they are catering to. A kidney hospital will have a different set of diseases. A cardiac care center will have different things. So usually different level of diseases will come at different level of the healthcare system. So whenever we are, mind the words now, when this is one MCQ, it is due to differential hospital admission rates that different hospitals or different levels of healthcare services will cater to different diseases. Where do you find a Bergsonian bias? It is predominantly, not predominantly, it is a very specific bias which is found in MCQ, hospital-based case control study. Hospital-based case control studies, you may find a Bergsonian bias. What do you mean by a Bergsonian bias? Last point, that in hospital-based, let us say I work in a cancer hospital, in a tertiary care cancer hospital. I wanted to do a study on esophageal cancer. The cause of esophageal cancer maybe I thought was alcohol. And I took esophageal cancers and I took lung cancers or breast cancers. So now whatever factor I am going to assess, in cases, that was my lung cancer. In controls would be, from where will I take the controls? I can't go to a PHC to select controls with the esophageal cancer from a tertiary Tata Memorial Hospital. So we have to take the controls from the same hospital. Now, whatever factor I was assessing in the cases, the same factor could be there in controls also. So primarily what I want to say is that people attending a hospital are usually exposed to similar type of risk factors. It is very difficult to delineate the risk factor in a hospital-based case control study where the cases might roughly be equal to the controls. Why? Because usually the type of risk factors are same. So anyways, if you understand it, very nice. But even if you don't, at least remember this, that what is Bergsonian bias? Can you remember that for me? That it is differential hospital admission rates. And second point you need to remember is it is predominantly specifically found in a hospital-based case control study design. Next is, what do you mean by Neyman bias? Another big headache is Neyman bias. Neyman bias. What do you mean by Neyman bias? That is, I think, your point number 8. So Neyman bias, beta, what do you mean by Neyman bias? First MCQ, it is also known as incidence prevalence bias. What is this incidence and prevalence bias? See, whenever an incidence happens, let us say that this is the world. Imagine that this is the world, this is the jug. You remember that new incidence cases will be there and some prevalent will be there. So if you have more incidence, technically you should have more prevalence. Let us say a disease is fatal. So you have more incidence and people die. So in the bucket, you will see very few people. Are you able to understand that? So now you do a study to find some disease. But where are those people? The people are outside the world. They have already died. So in cases with, that is what is Neyman bias, in diseases or in conditions or in health-related states events with higher mortality, the people on whom you are testing or doing investigations or doing experimentations or doing interventions, that population may be entirely different from the people who had already died. Because they are the survivors now of that disease, and the disease was supposed to be a lethal disease. Are you getting it? So you can't say that my intervention saved them, because the people were already dead. Are you able to get that Neyman bias? It's a beautiful bias, but for your MCQ exams, I'm not trying to scare you out over here. It is an important bias. It had been asked in your MCQ exams 3-4 years ago. So Bergsonian bias, everybody knows. The next level of exam would be always Neyman biases and Hawthorne effects. So just remember for your exam beta, what is a Neyman bias? It is incidence prevalence bias. So it is more found in conditions with high mortality. A very simple example, if you're thinking that why I'm getting confused right now, a very simple example I would like to give you. Let us say that you are doing some study on coronary artery disease or ischemic heart disease, or what do you call as myocardial infarction, right? Where will you find the MI patients? I'll find them in a hospital. So let us say I'm talking about, this was actually a real study. I'm talking about physical exercise. I feel my research question is that physical exercise maybe has some effect with ischemic heart disease or the heart attacks or the myocardial infarction. So let us plan to do a study on ischemic heart disease. So where will I go? I will go to a cardiac care center. In the cardiac care center, I will go and ask them, Bhaiya, did you do physical exercise? Were you doing exercise? And I take another controls over there, or I ask other people, maybe with congestive cardiac failures. So people with congestive cardiac failures, they will always say that, nah, we did not do exercise. But there is a possibility, think on this line now. There is a possibility that the people who actually you are asking, the MI patients who are there in the hospital, they must have survived the MI. That is the reason they are in the hospital. So in MI cases, all the cases, very few reach hospital. Maximum, don't you think, will actually die because of the massive heart attacks? They could not even reach the hospital so that you could actually ask them. So the people who were survivors, people who reached the hospital, don't you think they were reaching not because they were reaching because they were doing a lot of exercise? So if you now go and ask them, Bhaiya, did you do exercise? They said, all my life I was doing exercise. So will you say that more exercise causes more heart attacks? Obviously not. Why? Because there is a problem with this bias. This bias is called as a Neyman bias, where the incidence and the prevalence is kind of hodgepodge. So that type of bias is called as Neyman bias. Anyways, for your MCQ exam, please note, hospital-based case control study, what is the answer? Bergsonian bias. Incidence and prevalence bias, what is the answer? Neyman bias. What do you mean by attrition bias? I think we have already had a word on this. What is attrition bias? Attrition bias is a specific bias which you found in cohort study designs. In cohort studies, we find a special bias, that is attrition bias. This is also called as loss to follow up. Loss to follow up bias, where you take a group of people and you try to do a lot of follow ups. Some people, they are not interested because you're doing a study. They just leave the study. That is what is attrition bias. Next is Hawthorne effect. Where do you find Hawthorne effect? Hawthorne effect is also found in cohort studies, or it could be found in any type of follow-up study designs, even in randomized control trials. What do you mean by Hawthorne effect? See, if your parents are observing you, you are a student, I am a student. If my parents are observing me, my family members are observing your girlfriend, boyfriend, somebody is observing you, don't you think that you change your behavior? We start opening more books that somebody is watching us. What is there inside the books? That is entirely separate story. You may be having a mobile phone right now and you look at more screens. What is there? You can just flip on, different apps are there, right? So you can always say that I'm studying Marrow all the time, but in reality, you could be doing social media all the time. So you tend to change your behavior when somebody observes you. That changing in behavior, Hawthorne effect is change in behavior while under observation. है ना? Change in behavior while under observation. That is what you call as a cohort design effect or a Hawthorne effect. Very important to understand the difference, subtle difference between Hawthorne effects and the next biases that I'm going to talk, that is the Golem and the Pygmalion effect. So primarily the understanding is that Hawthorne bias is whose problem? Is it the observer problem or the subject problem? It is the subject problem, because subject changed because of being observed. Now come to understand what do you mean by Golem and Pygmalion effects. See, let us say there are two groups, group A and group B. I do check their systolic blood pressure and I give them a drug A, and I check their systolic blood pressure in the group B and I give them a drug B or a placebo. I don't know what is drug A, I don't know what is drug B. And then I check their systolic blood pressures again, I check their systolic blood pressures again after 1 month. Let us say, I don't know how it happened, but the researcher A, he was such a funny guy, he never bothered to go to that population. He did not check their BPs again and again. But I don't know why this fellow was too much enthusiastic. The researcher B, he was kind of very aggressive fellow. So he went to the population, gave them you check the BP first time, and he gave them the drug B. So the drug B he gave, and he used to go there morning, afternoon, morning, evening. Every day he went for 1 month, and he used to keep a very strict record of the blood pressures. Don't you think the population, if somebody comes and check my BP again, morning, evening, I will stop doing everything and I will start doing physical exercise because somebody is checking my BP again and again. So primarily when the researcher is very aggressive, mind the words now, the researcher is very aggressive, or if the researcher has very high expectations, or the researcher is highly motivated, what will happen to your results? The results will be down or they will be virtually high. They will be apparently high because people will perform more. Are you getting it? So if people will perform more, that is, there will be a reduction in systolic blood pressure. Was it because of the drug? The drug, I told you, maybe it could have been a placebo. The decrease in the systolic blood pressure was not due to the effect of the drug. It was actually due to the aggression or the motivation or the exaggerated response by the researcher. That type of effect is called as a Pygmalion effect. It's a Pygmalion effect, okay? And on the other hand, come to this, our cool fellow, researcher A. He was the coolest person on earth, have something and not doing anything. So he didn't bother to go. So even if your drug A was the best telmisartan, if it was the best antihypertensive drug, the systolic blood pressure did not rise. Why? Because he didn't even bother to do that. So there is unmotivated researcher, or there is less aggression into them. So they will make a gola out of the result. Gola out of the result called as a golem bias. It will make a zero out of the result, that is called as golem bias. That's how I have remembered. If somebody is, there might be some subjects in your MBBS curriculum also, na, which you love the most, which you want to read the most. Why do you think you want to read the most? Because probably you must have understood them more, or probably somebody must have taught you in a much better way. That is what is a Pygmalion bias. But there are some subjects, I don't want you to name out anything loudly right now. There are some subjects which you will hate them. You'll not study them at all. Whatever come may, I'll not study this subject. So don't name them. So that probably that people were not motivated, they were not able to understand, they were not able to deliver the subject to you in a proper fashion. So probably that is what is a golem bias. So when the expectations are very high, you are going to perform. That is what is Pygmalion bias. Just remember this for your exam. So whose problem is the Pygmalion and the golem? The people will change, but the people will not change because they will change. The people will change because the researcher will make them change. So Pygmalion effects, just remember for your exam, Pygmalion effects is exaggerated response, which is usually a virtual exaggerated response. And this exaggerated response is because of what? Because of increased motivation or more aggressive researcher. What is a golem bias? Golem effect is blunted effects. To a person, you say that you'll never pass, you'll not do, nothing in life is going to happen. That person will automatically not do anything. That is what is the golem effects. So blunting of the effect because of unmotivated. Please note, it's a researcher problem. It's unmotivated researcher, or there was no funding for the research. No funding, how can we do anything? So that research is not going to yield any effect. But if there is a lot of funding, people are motivated and people will dance around and they will bring out the result. That is what is an exaggerated response or a Pygmalion effects. Next is, sometimes the examiner may also be interested to ask you, like, what do you mean by a confounder or a confounding variable? So let's have a look at what confusion is there in the confounding variable, beta. Let us say that there is any factor that you want to assess. I'm not saying it's a risk factor or a causative. Any factor you think that it may be causing a disease. So you try to assess it. Does it cause a disease? Yes or no? So now you actually find out that yes, it causes disease. More this factor, more the disease. Less the factor, less the disease. And you somehow prove that there is a chance that probably this factor is causing the disease. Now let us assume, I'm taking a hypothetical example, that what if I say that there is another factor which is the real risk factor. Now you say that the factor causing a disease, there is another factor which may actually be causing the disease. If this factor was the real risk factor in causing the disease, so there is a hypothetical situation that the risk factor was also associated with your factor. So that means more the risk factor, the more this factor. So therefore, now try to understand this risk factor is causing the disease, and it is causing the disease via the more risk factor also. So now you are having a look at this only. So this factor, this new factor that you are trying to assess was actually a confounding factor. It is actually a confounding variable. So what is a confounding variable? For your exams now, let's write it down. What is a confounding variable? Confounding variable is a variable which is associated which is associated with disease. It is also associated with the risk factor. So any variable which is associated with both disease, that's what you have seen, with both the disease and the risk factor, that factor may be a confounding variable. There is beta a third part to this definition also. So what is a confounding? Associated with disease, associated with risk factor, and also it may sometimes, it usually would be indirectly associated with the disease, but sometimes it may also have some effect on the disease. It may directly have some effect or not have any effect, So what do I mean by not have any effect, or if there is indirect effect or there is indirect association? What do we mean by this? So let's have a word, before I come back to the confounding, let's have a word about associations. So how many types of association do you know? We know 3 types of association. The association could be a direct association. That means one factor causing the disease. That is, it is a direct association. Or it could be an indirect association. That means there is some third variable which is associated with the disease. Or there could be another type of association that is called as a spurious association. What do you mean by a spurious association? That means that in reality there was no effect and there was no association. Mark the word, there was no association. It's just a virtual thing you are seeing. So try understanding what do you mean by association. Association means presence of 2 things at the single time. What is correlation? In biostats, you've heard about correlation. One increase, second increase. One decrease, second decrease. That is correlated. Association means presence of 2 things at the same time. You enter into a room, you switch on the fan, you switch on the light. Both are associated, but they're not correlated. The fan moves at 5, the light does not move at 5. So that is not correlated, that is associated. But there could be sometimes spurious association. As I enter the room, I have my blood pressure and the light is there. They both are there at the same time, but it does not mean light causing my pressure or my pressure causing the light. So that is not any association. It has no biological standing. It has no physical standing. That is what we call a spurious association. So coming back to your confounder beta, the confounder may have sometimes, I'm telling you now this with the quote, it may sometimes, very rarely, it can have some little effect. But the real factor is never a confounder, right? So the confounder may have some effect or it may not have a direct or any type of effect. That is called as a spurious association. So how do you find spurious association? You need to understand that whether it's a confounding, yes or no. So now problem comes, when do you say there could be some effect? So now let me dive into confounding. So whenever we have any factor and you think that this could be a factor which is causing a disease and maybe you have the real factor which was already there. So what you do is you do stratification. What do you mean by stratification? You stratify based on the real factor. So what you do is you take the population or you take the sample and you stratify based on the real factor. So you stratify based on the real factor. Let us say this population is there and you stratify that this is my yes or no, real factor there or no, not there. And within this factor, now within this zone, you see whether the factor you were assessing, was it causing disease, yes or no. So in case on stratification, so take home summary is in case on stratification, you find that there is an effect which is found. Effect was there. Some little effect was there in spite of stratification. Then we say that whatever variable you are saying, that variable is called as an effect modifier. That actually has some effect modification, effect modifier effect or effect modification effect. So that variable is called as effect modifier, or mostly what we happen to have is on stratification, we found out no association. There was nothing more disease or less disease. So that is called as the real confounder. So in very simple words, confounding variable could be of 2 types. That is, it could be a real confounder, that means a spurious association, or it could be an effect modifier where there is minimal little bit effect. So that is what you need to study for confounding, and that can be asked in your exam. The next topic that we are going to take up is treatment of bias, right? We have already covered about bias and what is confounding. So how do you treat bias and confounding? Treatment of, first let us talk about bias. Please remember B for bias, B for blinding. B for bias, B for blinding. How do you treat bias beta? We treat it by blinding. How many types of blinding do we know? Blinding can be of three types. We know single blind, double blind, and we also know a triple blind. In a single blind, S for single, who is blind? Subject is blind. In a double blind, who is blind? D for double, D for doctor, plus the subject will be blind. So both are blind. Triple blind does not mean T. So triple blind is the doctor is blind, plus the subject is blind, plus the analyzer is also blind. Analyzer is who? Who is analyzer? It is the statistician. Statistician is also blind. Please do not answer experimenter is blind, or the researcher is blind, or the epidemiologist is blind. The person who is doing the study, how can we blind ourselves? Can I make a study by blinding myself that I don't even know how to conduct a study? Is it even possible? So many students answer it that the researcher was blind, sir, epidemiologist is blind. Please note, in a triple blind, the statistician, the person who's going to analyze the data, they are blind. So technically speaking, you can have different types of blindness: single blind, double blind, triple blind. Very simple MCQ. Which of the following is the most common type of blinding? The most common type of blinding is a double blind. Which is the best type of blinding? The ideal type of blinding or the best type of blinding is triple blind. Next is, how do you treat confounding? How do you treat the confounder? So you remember confounder. Confounder is any variable which is associated with the disease, associated with the risk factor. It causes the disease spuriously or it causes indirectly the disease. So either the confounder could be a confounder or it could be effect modifier. How do you treat confounders? If you know that what is the confounder, you already know that alcohol is a confounder in smoking causing cancers. So we know that alcohol is a big time confounder. So whenever we are talking of confounder, if you know the confounders, you can have some known confounders. How do you treat known confounders? That is treated using matching. How do you treat unknown confounders where you don't know the confounders? The unknown confounders are treated by RSSR. R stands for randomization, stratification, standardization, regression. So how do you treat known confounders? Matching. How do you treat unknown confounders? RSSR, randomization, standardization, stratification, regression. So just remember this for exam. Next MCQ. Out of this, there is a word called as randomization. Please note that randomization is a universal treatment. Randomization is a universal treatment. Why do I say so? Because randomization is in reality a universal treatment. You remember I told you for bias, how do you treat bias? We treat it by blinding. But you also know that randomization can help in removing which bias? Randomization removes which bias? We studied that in experimental epidemiology. You studied that many times, that randomization removes selection bias. So selection bias, which is one of the big problems in biases, selection bias is removed by randomization. So can I say that bias is treated by both blinding? Can I say that bias is treated by both blinding and randomization? If you get single best answer, what is the best answer you would like to mark? Blinding. Next, how do you treat confounding? Confounding can be known confounders, unknown confounders. Known confounders are treated by matching and randomization. Randomization can be used anywhere. It's a paplu. It's a card in the whole deck of cards. So please note that randomization is anywhere. So which is the best answer you would like to mark for known confounders? The single best answer would be matching. However, if you get two best answers, mark matching and randomization. Unknown confounders, how do we treat? Unknown confounders we treated by RSSR, where the R again means randomization. So please note, randomization is everywhere. Randomization is a universal treatment. Randomization is a universal treatment. Single best answer is this. Matching is for known confounder, blinding is for bias. Next is, which of the following is the most commonly used method for treating unknown confounders? It is stratification. Please note, stratification is very frequently we stratify the things, and based on stratification you can treat any type of confounders. So stratification is most commonly done. Randomization is one of the heart of the randomized trial. Please remember this. Next, coming over to topic number 3, what do you mean by the criteria of causal association? So you remember that what was association? I told you association, just now we talked that association could be direct, indirect, or spurious. Spurious we are not bothered. Indirect is what is a confounder variable or effect modifier effect, and association could be direct. So when do you say that the association, when do you say that the association is a causal association? That means there is a direct. So there has to be a criteria of association. The criteria was given by Dr. Doll and Hill. It is also called as the Hill's criteria of causality or the causal association. So what are the causality criteria? So you can have these 6 criteria, 1, 2, 3, 4, 5 and 6 criteria of causal association. The first criteria is biological plausibility, specificity of association, temporality, dose-response relationship, coherence of association, and validity. So if you talk about each of them now, what do you mean by biological plausibility? Very simple. There's no MCQ that what does this mean, but just for your understanding, I'm telling you what is biological plausibility means. There should be some biological explanation, common sense. There should be some biological explanation. My eyes are blinking and there is some BP. So both are there. But the blinking of eyes does not cause an increase or decrease in my blood pressure. There's a nonsense, right? So there should be some biological explanation. Specificity means the same risk factor should cause the same disease every time only. Same disease only all the time. So the Cox bacilli or the Mycobacterium tuberculosis should cause TB. It's not that TB bacilli may cause cholera sometimes Salmonella typhoid or something. So TB bacilli should cause TB. Cholera bacteria should cause cholera. So things like this. This is same risk factor should cause the same disease. That is a unifactorial disease causation. Next is, what do you mean by dose-response relationship? Dose-response relationship means that if the risk factor is more, the disease should be more, or vice versa. That is, the risk factor is less, the disease is less. They should have the in proportion. So more risk factor, more disease. What do you mean by temporality? Temporality means very simple. Temporal means space in time, right? So in time, the risk factor should always be before the disease. So the risk factor should always means always. It should always be before the disease. That is what is temporality. What is coherence? Coherence means every time the risk factor should lead to disease. LT means lead to. SHLD means should. Risk factor should lead to disease every time. The focus is on the word every time. So it's not that sometime TB bacilli will cause TB, other times it won't cause TB bacilli. So that is coherence. Validity means that the investigation that you're using, they should have reasonable sensitivity, specificity, and the results should be valid. The criteria should be valid. The criteria of disease, the criteria of risk factors should be valid, and there should be reasonable sensitivity, specificity of the investigations. So if you understand this, MCQ asked us now, which of the following is the most essential criteria of causality? Please note that the most essential, without which you cannot say this is causal, is temporality. Temporality is the most essential criteria. It has to be established. Most essential is temporality. Next is, which of the following is the most difficult to establish? Or sometimes we don't even do that. Or sometimes it's not even possible to comment on this criteria of causality. Common sense, I think many of you must have got it. Specificity of association is the most difficult criteria. Because why? Because common sense, we nowadays have multifactorial causation. It's not that the same risk factor will cause the same disease. Smoking can cause hundreds of problems, right? So the same risk factor will not cause the same disease only. It can cause many other things. It can cause many other problems. That is called as web of causation or multifactorial causation of disease. So these are about the Hill's criteria of causality. So just now to summarize the whole game for you. So what you have studied till now is you know about case studies, you know about case series, you know about cross-section studies, you studied about case control studies, you studied about cohort studies, you studied about non-randomized clinical trials or randomized clinical trials, you studied about systematic reviews, meta-analysis. Am I correct? These are the study designs which you have earned and learned in the last 2-3 hours or 4 hours, whatever time. In these study designs, you already know that case study and case series, these are descriptive studies. You already know that case control, cohort and cross-sectional, these are analytical studies. You already know that these both are types of observational studies, and you already know these are type of experimental studies. And systematic reviews and meta-analysis, these are types of the evidence-based medicine studies. You already recall that in cross-sectional, we find out the prevalence of disease. In case control studies, you find out the odds ratio. In cohort studies, we find out the incidence of disease, the relative risk, the attributable risk, and the population attributable risk. You already remember that in randomized control trials or the clinical trials, we can calculate what? Do you remember? We can calculate the intention to treat analysis, or we had the per protocol analysis, or we could also calculate the number needed to treat or the number needed to harm. Number needed to treat or the number needed to harm. You also know that in meta-analysis, we can find the forest plot, and by the forest plot, you can find the median of all the medians. Do you remember this? Now, MCQs now. Beta, which of the following studies, you have so many case study, case series, cross, and this whole journey has taken you 3 hours, 4 hours, right? So in this whole journey, can you tell me which of the following study design is the best to tell you causality, that yes, this is the risk factor? I'm not saying that this may be the risk factor. This is the risk factor is given to you by meta-analysis. Am I correct? Meta-analysis is the best study design to establish causality. You remember, if you just pause this video and go back to the first video, the first line that I said in epidemiology, do you remember? I told you what is epidemiology. I asked you, you told me that it helps you in finding what? I said that in one word, if you ask me what is epidemiology, that is to establish causality. And that's what you're trying to understand after 3-4 hours of understanding epidemiology, that we are trying to say that yes, this is the factor. A very frequent example that I normally give to the students is, let us say, God forbid it never should happen with anyone. Let us say a student appears for the exam and could not clear, any ABC student. So, beta, if a student is appearing for the exam, there could be hundreds of reasons that the student could not clear the exam. The weather was not good, family problem, parents were not okay, brother-sister problem, girlfriend-boyfriend problem, studies was not done, you were not having, physiological state was not good, whatever. There could be so many factors which cause a disease or event to happen. Out of these factors, which is the most important factor that science is going to tell us is being told by epidemiology? So which of the following is the best study design? Please note it is meta-analysis. Which is the most preliminary study design? Which are the most preliminary study design? The most preliminary study design are what are the case study cases. I'm not saying that they are bad and meta-analysis is best. No. I'm not saying this. We cannot do meta-analysis until and unless we have the experimental studies or the case studies or the case control studies or the cohort studies or even the case series also. So the point I want to make over here is that I'm not saying that the meta-analysis is one of the best studies or case studies, case control series, they are not very good. I'm not saying this. What you need to understand is that we cannot conduct the meta-analysis until and unless we have the results from the clinical trials or the case control studies, cohort studies, case series. So this whole journey is going to establish causality. So first we need to do descriptive studies, then we switch over to analytical, and then we talked about evidence-based medicine. That's how always it is. And this phenomena is what we call as the hierarchy of causality. So this is what you see is hierarchy of causality, that you move from preliminary studies to one of the best associations. Next MCQ. Next MCQ is that out of this journey of 3-4 hours, out of these study designs, can you tell me that which of the following study design is going to give you the best measure about the natural course of disease, that how the disease happened over time. The natural course of disease is best given by natural course of disease is best given by the natural course of disease, or the natural history of disease is best given by cohort studies. Very frequently asked in your exam. This is a very frequently asked MCQ. Next MCQ. Which of the following study design is the best study? We already discussed it is meta-analysis. The preliminary studies is this. Next point is that in the descriptive studies, what will you do? There is something called as hypothesis. You understand the word hypothesis? What do you mean by hypothesis? Hypothesis, it means any assumption. I feel anything which has no proof. No proof. Any hypothesis is any assumption which has no proof. So what do you think about this? Which study designs are going to make hypothesis? Making hypothesis is done by meta-analysis or experimental designs or observation study designs or the descriptive study designs. Please note that formulation of hypothesis. I think that maybe this is the cause. This is given by the descriptive studies. Descriptive studies help you in formulation of hypothesis. Descriptive studies will help you in formulation of hypothesis. Next MCQ. Which of the following study designs will going to test the hypothesis? Whatever hypothesis has been formulated, which will be testing it. Please note that the analytical studies, they are known for testing of hypothesis. They are going to testing of hypothesis. Testing of hypothesis is done by, please note, testing of hypothesis is done by analytical studies. Formulation of hypothesis is done by descriptive studies. The experimental study designs and the evidence-based medicine. The experimental study designs and the evidence-based medicine, they are done for what? They are going to validate the hypothesis. They are going to validate the hypothesis. Validation of hypothesis. I'm sorry for just putting everything on a single screen, but I had to do this because we are talking of 3-4 hours of understanding. So please note, validation of hypothesis is done by experimental designs and evidence-based medicine. Testing of hypothesis is done by analytical studies, and the formulation of hypothesis is done by preliminary studies, that are the descriptive study designs. So that was your summary of the epidemiological methods. Next in line is numerical problems. Let's have just 2 MCQs I'm going to discuss over here. First MCQ is a researcher conducts a case control study to evaluate the risk factors for low birth weight in 200 females attending the antenatal care clinic and admitted under labor room in Department of Gynecology. The outcome was 100 females with low birth weight babies and another 100 females with normal or above median birth weight babies. The females were then asked about the questions related based on the factors influencing pregnancy and its outcome. So the results were obtained are as under. So these are the results that you see on the screen right now. So low fat intake, some of the options were there, low carbohydrate. They had calculated something called as the OR and 95% CI. We don't know whatever it is. And which of the following factors may show causal association? That is what the question is. So how are you going to solve it? The question is pretty simple, that there were some females attending the ANC clinics and the outcome was low birth weight babies, and they tried to assess about the different factors were being asked. So these were the various factors. So which of the following factors will show a positive association? It's a very direct MCQ. You remember what was odds ratio? Odds ratio is a cross product ratio. Odds ratio is a cross product ratio. Odds ratio is A into D over B into C. Odds ratio, if it is equal to 1, it means no association. More than 1 means positive association. Less than 1 means negative association. We already did this. So now just look at the odds ratio over here. It is such a simple MCQ. Which of the following odds ratio is showing a causal association? That means which odds ratio is more than 1. That's what it technically means. So 0.4 is what? Protective or causal? It is a protective. What is 4.7? It is a causal. So causal, 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 and causal. Other ones are protective association. Am I correct? Am I correct? The green shaded are the protective, the red shaded are the causal association. Now the point comes over here is how many will show causal association? So I see 1, 2, 3, 4, and 5. So according to me, the answer is 5 things are going to show causal association, 5 factors. But the answer may not be correct. Why? Because they have also given you odds ratio, 95% confidence interval of the odds ratio. Please note that what does this mean? 95% confidence interval. If you just look at the table again, can you see that this is 4.7 and this 95% is ranging? Try understanding this, visualize it in space. Let us say that this is 4.7, this value is 4.7. So the question, the 95% CI confidence limits are saying it is ranging from 0.8 till 9.5. So on a number scale, 0.8 till 9.5 and 4.7 is somewhere in between. Are you able to get this? So just draw this on a number scale. So common sense, if the 95% CI is saying that the lower limit is 0.8. What is 0.8 odds ratio? It means a positive or a negative. Common sense, it is a negative odds ratio. 9.5 is a positive odds ratio. The median answer is a positive odds ratio, but it ranges from minus to plus. So what do you say to this odds ratio? This odds ratio beta is showing either indirect effect or a spurious effect. This is a confounder. Are you able to understand what is this? This is what is the table for regression analysis. This is what I have shown you is a regression. I hope the words that are coming out, you are able to understand what are these words. This is what is a regression analysis. And you see that this odds ratio, it looks like to be a positive odds ratio, but in reality, it is not having any significant effect. So what is this? We say it is a non-significant odds ratio. Are you getting it? Now you look at the other ones and you'll come to know. So what do you think about 5.6? It is showing from 1.2 to 9.5. That means it is always positive. That means this is called as a significant. This is called as a significant positive odds ratio. Are you getting it? So in very simple, very desi words, I would like you to understand that if the confidence interval, the number value 1, if the value 1, it lies within the 95% CI range, 1 will lie within this range, then the odds ratio is a confounder. It is a non-significant. If the value 1 is outside, either it should be positive or it should be negative. You can't say that sometimes it was a protective effect and then 1 is where lying, 1 is lying here. So sometimes it is protective effect, sometimes it is no association, sometimes it is positive. This is a confounder effect. Are you able to get it? So just look at the table. It is so simple to understand this research analysis that which of the following will show a significant odds ratio. So if you talk about alcohol, yes, it is a significant odds ratio. This one, can you see about this? Can you see for this one, 1.3? What is 1.3? It is a non-significant odds ratio, although it is a protective, although it is a risk factor, but it is a non-significant risk factor. Can you talk about the stress level? Yes, definitely it is showing a significant risk factor. Significant risk factor. Smoking always shows a significant risk factor. So how many factors are actually having causal association? 3 is correct, 5 is wrong answer. Are you getting it? It's such a simple MCQ. I don't think we need to put any brain on this. So please remember, if within the 95% CI, if you see one value, answer is a confounding variable. Next MCQ, question number 2 for you guys. You are considering how useful a new treatment might be in preventing a stroke, brain stroke. A well-designed study is reported with 200 patients in the treated group and 200 patients in the untreated. So now this problem is talking about what? About the case control study, cohort study, or the randomized clinical trial. common sense, this question is talking about a randomized clinical trial. If nothing is said, it is a randomized clinical trial. The study finds a 5-year risk of stroke of 3%. So there were two groups, Group A and Group B. To Group A, they gave some treatment and Group B was untreated. So in Group A, they got 3% as the level of the stroke, and in the treated group, and 5% in the untreated group. Assuming the study is valid and applicable to your patient, how many patients would you have to treat for 5 years to prevent one stroke? So technically, this is what I have added, but in real exam, nobody will tell you that they are talking about the number needed to treat. So do you remember what was the formula for number needed to treat? I know it's such a big torture for you guys, but I'm sorry for this, but that's how it is. Number needed to treat. Do you remember it was given by the formula absolute risk reduction inverse? You inverse the absolute risk reduction. What was absolute risk reduction? That was CER minus the EER. What was CER? That is the control group event rate minus the experimental group event rate. You remember this? This is the formula for number needed to treat. So if you know that this is the formula for number needed to treat, what is the answer? So they had the MCQ wala is trying to confuse you with so many data. But in real sense, the only data you know you need is 3% in the treated, and in control group it is 5%. So what is the event rate in the control group? Common sense, it is 5%. What is the event rate in the experimental group? Common sense, it is 3%. You do not need to make the table. So the table, even if you want to make the table 200 patient and 200 patient, let's make a table. Okay, so this is the experimental group and this is the control group. If you are just pressurizing me to make the table, you make a table yourself also, you will understand it is the same answer. So this complication, this is no complication. In 200 people in the experimental group, it is 3%. So 3% of 2 is how much? 6. 5% of 2 is how much? 10. Remaining 190, and over here 206 is 194. So that means if I just want to draw the experimental, I want to find out the experimental event rate, right? What is the answer? Again, your common sense, experimental event rate will be 6 out of 200 only, na? One is you find out 3% of 200, that is 6. Now 6 out of 200 will be how much? It has to be 6 out of 200 is equal to 3. Are you able to get what I'm saying? You do not need to draw the box. So just remember, the MCQ wala, they directly gave you. So this whole thing you don't need to study. If you are able to solve these 2-3 types of MCQs, you will crack the exam with the highest marks. These are the MCQs, beta, which will define whether you will be in department A or B, or whether you will be in department of radiology or dermatology or fancy department of medicine or the fanciest department of surgery, whatever your orthopedics, whatever your dream branch is. So these are the MCQs which will define that you will be in department of community medicine or in department of orthopedics. These are the MCQs, right? So just try to understand that these are the things you need to know. So very simple. If you just calculate it now, what is the answer? It is 1 over 2, na? 1 over 2 means what? 1 by 2 is 0.5%. So always number needed to treat. I told you it is the number you need to treat. It's not the percentage. So 0.5% means 0.5 into 100, that is equal to 50. So common sense answer is over here is 50. Are we getting it? So it's within 2 seconds you can get this answer, and then students will say that, sir, there was no pen and paper. But yeah, why do you need a pen and paper over here, right? So with that, we have covered this whole section, this whole chapter on epidemiology. Beta, if you have understood epidemiology, do a favor to me, that go home and teach someone this whole beautiful chapter on epidemiology. This concepts of epidemiology will be embedded into your gray matter, and the MCQs will become water for you. All the very best. See you in the next chapters next time.